Okay, first I will explain what you mean by one-to-one function, right? So if it is a one-to-one function, right, each element in the codomain is the image of at most one element in the domain, right? Did you understand the point? If it is a one-to-one function, right, each element in the codomain, right? So if you look at here, wait. If you look at a function, right? So we are not notated by a graph, right? This is the codomain, right? So this is my codomain, right? So one-to-one function mean each element in the codomain, right? Each element in the codomain, each element in the codomain is the image. So each element in the codomain is the image of at most one element in the domain, right? So it means if you look at, let's say here, right, if it is a one-to-one function, if you think about each element, right, not every element, uh, just consider the different. Every elements means all the elements in the domain, all the elements in the codomain, right? I'm not telling every element, so, right? If you pick each element, these codomain elements is the image of at most one element in the domain, right? So it means all the elements in the domain have an image on the codomain, right? The important thing, at most one image, right? So if you look at here there are three elements in the domain, right? In the domain side, we have three elements, right? So all the three elements have an image with the relation assigned with codomain. But the important thing, this codomain element only have a relation with one image, right? At most one means maximum one image they have relation, they have assigned, right? So maybe this way and this way, right? It is not mandatory all the codomain element have a image, but all the domain elements must have a image with codomain element, must have an image of codomain element. But if you look at here, right, it is not possible, right? Just I will draw, right? This is called one-to-one function, right? So if I draw this way, this is also a function, right? This is also a function, but here what will happen, for the codomain element one have two images, have a two relation with a and b, right? So this is not a one-to-one function, right? To become a one-to-one function, what will happen, each codomain element have an image of at most one element in the domain, right? So maybe it can be this way, right? This way means four has a codomain element have only one image with B, the relation with B. Similarly, one is a codomain element have a relation with A. Similarly, B has an image with 4, right? So this is important, right? Each element in the codomain is the image of at most one element in the domain, right? So the hidden meaning, two different domain element have the same output, right? So the internal meaning says two different elements in the domain, they don't have the same image. They don't produce the same output, right? So this is the hidden meaning, right? Two different elements, A and B, two different elements in the domain, right? They don't have same output one, right? They don't have same output. So if it this way, we can say this is not a one-to-one function, right? Two different elements in the domain, two different elements in the domain not produces the same output. That is, we can say one-to-one function, right? So each element in the domain have a different image, right? There is no same image. That is the internal meaning of this one, right? That is we can call one-to-one function, right? The next one, onto function, right? The onto function means in here, the previous case, one-to-one function, we are not consider every element in the codomain, right? But if it is a onto function, if it is a onto function, right? All the elements, each and every element, all the elements in the codomain. So every elements in the codomain have at least one, right? At least one mean minimum one, maximum more than that, right? So if it is an onto function, every element in the codomain has at least one pre-image of domain. Did you get my point? In the previous case, if it is a one-to-one function, right? Each element in the codomain is the image of at most one element in the domain, right? It means there is two domain element have the same output. That is one way here. If it is a onto function, every element in the codomain. So here, if you have in the codomain 4 elements, each and every element have relation with the domain, at least one relation, right? So here, let's say A, B, C, right? The important thing, all the elements from A to, for all the elements from 1 to 4, definitely they have a relation with domain. Not image and elements are not same, right? Image in the sense, if they have a relation, those images we can call, those elements we can call images, right? So that the elements and images are not same, exactly same, right? The entire set we can say elements, right? So here, 1, 2, 3, 4, just look at here in the previous case. If you look at here, 1, 2, 3, 4. This is elements of codomain. A, B, C is element of domain, right? Image in the sense, only the elements which have relation with domain, right? So images, we are consider image only for the codomain element, right? Only codomain elements are called as an image, right? So one is an image of domain element A. Two is an image of domain element C. Similarly, 3 here, right? Similarly, uh, Similarly, 4 is an image of element B, right? So image is only for the codomain element which have assigned with domain elements, right? So elements mean all the things, all the things. Here, images, if I ask what are the images, you need to answer 1, 2, and 4 are the images, right? 1, 2, 4 are the images, right? So if I ask you, what are the elements of codomain? Codomain elements, then you can include 1, 2, 3, 4, right? All elements we can call codomain elements. But if I ask image, you need to check only the elements which have a relation with domain, right? So if it is a onto function, the important thing here, all the elements, right? All the elements in the Can you tell me, is it a one, it is a onto function. Is it onto function? No, right? Because why it's onto function? It is not onto function. Why? The definition says every element every element in the every element in the codomain has a relation with domain elements. Here, at least one relation, right? Every element in the codomain has at least one image in the at least one relation with domain element. So here, if you look at here, if it is a onto function, all the elements in the codomain must have a pre-image of the domain. But here what will happen, 3 is an element in the codomain. There is no relation. So we cannot say, we can say this is not a onto function. We can say this is not onto function, right? To become an onto function, what will happen here? Maybe you have a, maybe you can create another element, right? Here I'm writing C and D, right? Now, C, D, E, right? Then, okay. Now, what do you think? Is it a onto function? This is not, even it is not a function, right? If to become a function, all the element in the domain must have a relation with the codomain, right? So maybe this is not a function. So first I need to, this is a function, right? Now, what do you think? Now, what do you think? Is it a onto function or not? What do you think? Is it onto function or not? So the definition says every element in the codomain. So 1 to 4 is the element in the codomain. They have a relation, at least one relation with domain, right? At least minimum one, maximum number it's possible, right? So if you look at here, the 4 is an element of the codomain. It has two relations, two assignments, right? So with the relation with D and E, right? What do you think? Is it a onto or not? Is it a onto function, right? Is it 1 to 1? Tell me. Now, depending on that, we can say this is onto function. This is onto function. Why it is onto function? All the elements in the codomain have a relation, at least one relation with the domain, right? That is onto. What do you think about it? Is it 1 to 1 or not? Is it 1 to 1? Is it 1 to 1? So what is the definition says for 1 to 1? Every element in the codomain, at most one image, right? Every element in the codomain has every element in the codomain is the image of at most one element in the domain, right? So if you think about here, I already told you two different domain element have the same output, but here D and E are the two different elements in the domain have the same output 4. So it is not a one-to-one function, right? Any questions? Hello. I don't know. You are not talking, right? Whether you are in the session or not. Any questions or not? Definitely you have some question, right? So try to understand those things. Don't even last year, half of the students are failed in the subject, right? Just think about that one. In your senior batch, around 50 students, sorry, 100 students, around 52 or something fail, right? Don't do the same mistakes by your batch as well, right? If you don't understand, let me tell, right? I will explain. Yeah, I will explain, right? So the one-to-one and onto, right? So one-to-one function means better you can understand the meaning, right? So one-to-one function means, right? The important thing here, this is domain, this is codomain, right? So if it is a one-to-one function, each element in the codomain, right? So 1, 2, 3, 4. These are the 4 elements in the codomain. Each element in the codomain, each element in the codomain is the image. Each element in the codomain is always image, right? Codomain elements are considered as images, right? So at the time, let's say in the domain we have 3 elements A, B, C, right? So each element in the codomain is an image of at most one element in the domain, right? So it means codomain elements always consider as images, right? codomain elements are, we know that they are the images. The condition says they are image as a only one. At most one means they are considered as a images of only one input element, right? So this is we can call one-to-one. This is we can call one-to-one function, right? So the same thing I will explain, right? I will explain this way, right? A, B, C, right? 1, 2, 3, 4. If you stay this way, right? This is also a function, right? This is also a function. This is also a function, right? But it break the condition for one-to-one. What is the condition for one-to-one? The condition for one-to-one says each element in the codomain is the image of at most one, maximum one element, one domain element. For the maximum of one domain element, it considers as an image. But here, there are two domain elements considered as the same output, right? It is not possible in the one-to-one function, right? If you look at the codomain element, definitely it has a relation with only one domain element, right? But here, this in this scenario, the codomain element 1 have relation with two domain elements A and B. So this is not a one-to-one function. But here, this one is a one-to-one function, right? The important thing, two different domain element have the same output. But here, A and B, two different domain element have the same output as a one, right? So we cannot say, we can say this is not a one-to-one function. But here, all, not all, here each codomain element have at most one element's image, right? Only one relation. So this is we can call one-to-one, right? If it is a onto function, if it is a onto function on that scenario, onto function on that scenario, all the codomain element have a relation with the domain element, right? The important thing here, how many there is numbers doesn't matter. Even if we have a n number of elements in the codomain, those elements definitely have a relation with the domain, right? Here, minimum one relation, right? Maximum of whatever the number, right? So here, important thing, each and every element in the codomain definitely have a relation with the domain element, right? So here, this is possible, right? Also, this is also possible, right? What do you think now? Is it onto function? This is not onto function. Why? The the definition says all the element in the codomain have at least one relation, right? So definitely now it's okay, right? All the element in the codomain at least one relation, right? Here, if you look at the codomain one, here they have two relations, right? It's possible in the onto function. So we can call this is onto function, right? So yeah, so if you have this way, right? This is not onto function, right? Why it is not onto function? The element 2, the codomain element 2 is not assigned with any images, right? At least one, if we have this 2 is assigned with at least one element, then we can say that is a onto function. Even we can put this way, right? Why we can put this way? This is breaking the condition of a function, right? If it is a function, one domain element have two different outputs, right? So this is wrong, right? Why? It is breaking the condition of a function, right? So we can't do this way. Maybe to convert into a one to function, maybe you have another element, right? Then that element assigned with this one, right? So these are the conditions for one-to-one and onto functions. Okay. Now the last form, right? Now you are clear with what is one-to-one and onto, right? One-to-one means every element in the codomain is an image of at most one element in the domain. That is one-to-one. Onto function means every element in the codomain has a relation, or it considers an image of at least one domain element, right? So that is one-to-one and onto function. The third one, invertible function, right? So we can say a function is a one-to-one and it is a onto, then we can say that is a invertible function, right? If the function one-to-one as well as onto function, then we can say that is a invertible function, right? So if a function can satisfy two things, maybe the function is a onto as well as the function is a one-to-one, then we can say that function have the invertible function as well, right? So a function a to b is invertible. When it comes a invertible, tell me if a function is a invertible, inverse function, when that function is a one-to-one as well as that function is a onto function, then we can say that function is a invertible function. Let's say if a into b is a function which is a one-to-one function and onto function, then this function have a inverse relation. The inverse relation we can say f of minus 1, f of to the power of minus 1. So this is the notation for indicate the inverse function, right? So inverse function is nothing, right? If you have a function f of a to b, right, that is a one-to-one and onto function, then it definitely this function have a inverse function. This function we can create the inverse function as well, right? So inverse function means the relation, the function from b to a, right? Previously a to b, now it considers a b to a, that is the inverse function, right? Let's say now think about, right? Let's say this is a, right? Uh, this is b, right? So if it is a function from a to b, so here a is a domain, b is a codomain, right? So if it is an inverse function, right? If it is an inverse function, codomain considers a domain, right? In here, if it is an inverse function, codomain considers this way, right? Codomain considers a domain and domain considers a codomain. That is inverse function, right? There is nothing. So how you can find out whether it's a function is a inverse or not? First of all, you need to check whether it's a one-to-one function. If it is a one-to-one function, then you need to check whether it's a onto function. If both is a one-to-one and onto, then we can say this function have a inverse function, right? I will explain how we can find out the inverse of the function, right? Okay, I will tell you to find out the inverse function, right? I will tell, right? Just think about f of x is equal to, okay, 3x plus 2, right? Just think about there is a function f of x, right? Just, just assume this function is a one-to-one function and onto function. In the question, they are telling you this is a one-to-one function and onto function, right? They are asking, write the f of inverse x. They are asking f of inverse x, right? How we can answer this question, right? First, look at here, right? This is the function of f of x. We need to find out the f of inverse x, right? So now just we can write y is equal to, right? Okay, I will write y is equal to 3x plus 2, right? So this is my function f of x, right? This is my function f of x is equal to, then I am assigning a letter y, right? So if I change the value for x, so what will happen? I am consider x is equal to 1, x is equal to 2. x is equal to 3, right? So if I change the value for x, I am getting a different y values, right? So here, the changeable variable is x, right? Even if I change the x, value of x, depending on the value of x, my y will change, right? Depending on the value of x, my y will change, right? Y means my function will change, right? To get the inverse function, right? Now here, this is the changeable value, right? For this x, I will change the value from 1, 2, 3, likewise, right? Depending on that, I'm getting the y, right? To find out the inverse function, right? From this function, I need to uh, change the subject as a x, right? Here the subject element is y. Subject means y. So y is equal to, that is the subject of the equation, right? I need to convert this equation as a subject as a x, right? How I can do that? So if I do this one, so y minus 2 plus 2, if I take this way, y minus 2 is equal to 3x, right? Then I can write, if I divide by 3 both sides, so I can get the equation x is equal to y minus 2 over 3, right? Now, if you look at this equation, what will happen, right? Previous case, so this x is a domain element. This is a domain, right? Y is the codomain. Y is the codomain, right? Y is the codomain. Now, what will happen? If I change the subject as a x, now what will happen? This y consider, or previously y is the codomain. Now, what will happen? If I change the value for y, depending on the value, if I change the value for y, x will change, right? So this is my inverse function, right? So now previously y is a codomain, right? Previously y is a codomain. Now it considers a domain. Domain means this side, right? If depending on the value I put for y, right? Depending on the value if I put for y, just look at here. So now I'm putting y is equal to 1, y is equal to 2, y is equal to 3. Depending on that, I am getting a value for x, right? So this is now considered as a domain. Now this previously this x is a domain. Now this x considers a codomain, right? Now I have an equation x is equal to y minus 2 over 3, right? So this is my inverse function, but we need to change this as a, so this is a inverse function of f of inverse y, right? Why I am telling here, previously f of x means this is a variable is x. Now here the variable is y, right? So I can write this one, f of inverse y is equal to y minus 2 over 3, right? But they are asking from the question, they are asking f of inverse x, right? How I can get this one? In this inverse function, I am replacing y is equal to x, right? Now what will happen? F of inverse x is equal to x minus 2 over 3. So this is the answer for the question, right? Did you understand? So inverse function, to become an inverse function, first you need to check whether function is a one-to-one and on-to. If they satisfy both conditions, then only that function f of x has an inverse function. To find out the inverse function, right, you need to clearly understand the concept, right? If it is a inverse function, let's say f a to b is a function. If this function have an inverse function, so we can write the inverse function as, so the inverse function is f of inverse x means f of b to a, right? Here a is a domain, b is a codomain. If it is an inverse function, b is a domain, a is a codomain. So if you have an equation, from that equation, if you change the subject of that equation, then that is the inverse function, right? So someone says inverse function is not clear, right? So just imagine f of x is equal to uh, 3x plus 5, right? This is a function, no? So this is a function means this is a function from A to B, right? So here, what will happen? For A, I am putting some element, right? So just imagine I am putting for A 1, 2, and 3, right? So here f of 1, f of 2, f of 3 are the images of, so this is B, right? So if I put 1, 2, 3, depending on the value. So I'm putting this 1, 2, 3 for what? So I'm putting x is equal to 1, x is equal to 2, x is equal to 3, right? So depending on that, let's say I'm getting f of 1 is equal to uh, for some value, f of 2 is equal to some value, f of 3 is equal to some value, right? So I'm writing here this f of x, I am writing this f of x is equal to y, then 3x plus 5, right? So if you look at this equation, right? So if you look at these values, what will happen? If I change the value for x, so it means from the domain, so x is a domain, right? So x, the value I am putting for x is a domain. Depending on the value I am putting for x, the equation will change, right? I'm getting different value for y. So these y values are, I'm considered as a codomain. So this is a function, right? If I assign a value for x, depending on the value for x, I am getting a value for y. That is my y value. That is my image, right? If it is a inverse function, right? If it is an inverse function means that is a function from B to A. That is a theory, right? If it is an inverse function means a function A to B have an inverse function means that function have a B to A. That is the inverse function. Inverse function means A to B a function. If it is an inverse function means that is that function have a B to A, right? So B to A means previously this B is the codomain, right? This is the codomain. A is the domain, right? A is domain, B is codomain. If it is an inverse function, in the inverse function, B considered as a domain, B considered as a domain because this way no, they travel from B to A. Now, if it is a B considered as a domain, A considered as a codomain, right? So now what will happen? Previous case, x values are domain, y values are codomain, right? So x values are domain, y values are codomain. So y the value we are getting for y is a codomain. If it is an inverse function, this y values consider as a, this y values and consider as a domain, this x values consider as a codomain, right? So if I have a equation y is equal to 3x plus 5, if you look at here, this is x. Previous case, x is a changeable value. Depending on the value I am putting for x, I am getting different y's, right? Now what will happen? Y consider as a domain, x consider as a codomain. So y consider as a domain means y is the changeable value. We are if we change the value for y, depending on the value for y, x will get different values, right? How I can change x is a sub for that one, we need to change the subject, right? Previously the subject is y, then we are getting y as a codomain. Now we need to change the subject as a x. Now if I need to change the subject as a x, then x consider as a codomain. So how I can change the subject? So y is equal to 3x plus 5 is an equation. So if I change the x as a subject, y minus 5. So this 5, if I go the next side of the equation, y minus 5 is equal to 3x, then we can say x is equal to y minus 5 over 3, right? So this is the inverse equation. Why I'm telling here? I told you y value considers a domain, right? So domain means if I change the value for y, maybe y is equal to 1 or y is equal to 2, depending on the value for y, x get the different value. So x is the codomain. So x is equal to y plus y plus 5. Sorry, y minus 5 over 3. So this is the inverse function. So if a function is a inverse function or inverse function, so this is the changeable value. This is a variable, right? So we can say f of inverse y is equal to y minus 5 over 3. But they are asking f of inverse x, right? So we even if it's correct, if the function f of inverse y, so f of inverse x means just we are changing the y as a x. So f of inverse x means x minus 5 over 3. Just you don't need to think about much more, right? If they're asking inverse function, first you need to think whether it's a one-to-one. You need to check whether it's a on-to. If they both one-to-one and on-to, then you need to change the, let's say if they are giving an equation f of x, then you can change the subject, then you can convert into f of inverse x, right? First you need to change the subject of that equation, right? Then you can change that inverse function into f of inverse x, right? You can understand if I look at some questions, right? Yeah, then we discuss those things, right? So up to now we discuss. So definitely it must be a one-to-one and on-to, then only we can say that function have a inverse function, right? If it is not a one-to-one and if it is not on-to, we cannot find out the inverse function for that one. I just clearly understand that one. Okay. Sometimes we can call different names, right? So one-to-one function we can call injective function. Sorry, injective function, right? Injective function. On-to function we can call surjective function. This invertible function we can call bijective functions. These are the different names for the function, right? One-to-one is an injective function. On-to is a surjective function. Inverse function we can call bijective functions. These are the different names, right? So just maybe if I ask injective function, you need to understand I'm asking about one-to-one. If I ask surjective function, you need to know I'm asking about on-to. If it is a bijective function, I'm asking about inverse function. Just understand, right? They have different names as well, right? Okay. Then we will look at an example, right? Just look at this example. There is a function f of 1 from a to b. Similarly, a function f of 2, b to c. There is a function f of 3, c to d. There is another function f of 4, d to e, right? So these are the four functions, f of 1 to 4. They are giving four functions, right? Now, okay, before you look at this one, okay. Okay. Now tell me which function is one-to-one, which function is on-to. Likewise, tell me if you understand what is one-to-one. One-to-one means each element in the codomain has an image of at most one element in the domain, right? So it means there is no two domain element have the same output, right? Then it is a one-to-one. On-to function means every element in the codomain have a pre-image of at least one element in the domain, right? So what do you think about F1? What do you think about F1? Is a one-to-one or onto or both? What do you think? So to become a one-to-one function, right? Each domain element have at most one relation. So this is with one relation, at most one image, one image, right? So then we can say F1 is a one-to-one function. So F1 is a one-to-one function. What about F1 is onto or not? What do you think? F1 is onto or not? This is not onto. Why this is not onto? So one-to-one function means if you look at each element in the codomain, they have at most one, they have an image of at most one element in the domain, right? So it means the two different domain element have the same image, right? Here there is no case on that way, right? Two different images have the same image. There is nothing, right? So it's a one-to-one function. If you look at onto function, each and every element in the codomain, they have a relation. But if you look at here, 3 is an element. There is no relation with the a, right? So this is not a onto function. This is not onto function. This is not onto, right? So I'm writing this way, right? So this is one-to-one. This is onto, right? So here this is one-to-one function, but not onto. How about F2? How about F2? Tell me. How about F2? So F2 is a function from B to C. So first you need to check whether it's a one-to-one. So to become a one-to-one, first you need to check this is a unique image. 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 So this is also a one-to-one function. How about this is onto or not? This is onto function, right? This is a onto function, right? Why? Each and every element in the codomain have a relation with at least one image in the domain. How about F3? F3, what do you think F3? No, I'm asking whether F3 is a one-to-one or not. One-to-one or not. Is it one-to-one? F3 is one-to-one or not? What about others? Only one or two guys answering the questions, right? So this is not
Yes.
one to, yeah, this is not one-to-one, right? So the function F3 is not one-to-one. Why? I already told if it is a one-to-one, two different elements in the domain, they don't have a same image, right? But here, just look at here, two different elements R and U, they have the same image B. Because of that, it is not a one-to-one function, right? The thing we need to find out why it is not a one-to-one. That is important, right? What about is it onto? Is it onto function? It is onto function, right? To become an onto function, each and every element in the codomain, only check the codomain elements. They have an image. They are the image of at least one element in the domain. Maybe more than one, at least one, right? So here this element is a V is an image of R and U. Similarly, W is an image of S and T. So this is a onto function. What do you think about F4? What do you think about F4? Is it a one-to-one or not? F4? F4 is not one-to-one. Why? F4 is not one-to-one. I already told you two different elements in the domain, they don't have the same output, so same codomain image. So because of that, this is not a one-to-one. Similarly, this is not a one onto as well, because X and Y are two elements. They don't have any relation with the domain elements. Because of that, this is not onto and one-to-one, right? Okay, yeah, just look at here. F1 is a one-to-one function, right? Our answer is correct. F1 is one-to-one. Why they are telling F1 is a one-to-one? No elements of B is the image of more than one elements of A, right? So in the B, we have considered as a image of function F. So there is no two elements of A have the same image. Because of that, we can say F1 is a one-to-one function, right? F2 is a one-to-one, right? Similarly, F3 and F4, they are not one-to-one, right? So this is correct. So this is correct. F2 is a one-to-one. Similarly, F1 is also a one-to-one, right? Then if you look at the onto, F2 and F3 both are onto, right? F2 and F3 both are onto, right? Every element of, yeah, onto means every element in their codomain have at least one relation, right? At least one relation, but at least one assign of their domain. Okay, now tell me which functions have inverse function. To become if a function have an inverse function, first thing they must have a one-to-one and onto. So depending on that, only function 2 has the inverse function, right? Did you get my point? If a function is a one-to-one and onto, then only they have a inverse function, right? So only the function f2 from A to B has the inverse function f of inverse from B to A, right? Other functions, they don't have any inverse function because they are not one-to-one and on-to, right? These are the ways we will find out, right? Okay. Now I will show you how to do some questions, right? Then we will move for the next topic, relations, right? Okay. Okay, just listen carefully, right? I will explain 3 to 4 questions, right? Okay, the first question they are telling you, X is a set from X is a set. They have elements 1, 2, 3, 4, right? Determine whether each relation X is a function from X to X, right? We already know f is a function from X into X, right? So this is called identical function, right? This is called identical function, right? So they are giving function f of f, g, and h. They are giving 3 functions, and they are asking whether these 3 functions are whether these 3 relations are functions or not, right? I already told you, maybe we can define functions as a relations. We can define function as a relation. So relation mean we define the elements as an ordered pair. First element is a domain element. Second element is the codomain element. So the important thing, this is an ordered pair, right? So if you look at the first question, if you look at the, sorry, if you look at the first first relation f, right? We know from the relation we can draw the graph, right? So if it is a relation, the first element is the domain, second element is the codomain, right? So depending on that, we can draw these function. Also, they are telling x is a set contain 1, 2, 3, 4, right? So first thing we need to draw the graph, right? So this is a identical function. Identical function means both domain and codomain have the same set. Domain and codomain have the same set of elements, right? 1, 2, 3, 4, right? So now what I need to do, I need to draw the arrows, right? So if I look at the first one, the domain is 2, right? Codomain is 3. So I can draw from this way, 2 to 3. I can draw this way, 2 to 3. If I look at the second one, domain is 1, codomain is 4, right? If you look at the third one, domain is 2, codomain is 1. If you look at the fourth one, domain is 3, codomain is 2. If you look at the fourth one, for domain and 4, codomain and 4. Now tell me whether it's a function or not. Whether it's a function or not. How you can find out whether it's a function or not? What do you think? Hmm? Just revise the theory to check the functions. Hmm? Each element in the domain have a relation with codomain, right? So this is my domain, this is my codomain, right? Each element in the domain relation with the codomain, right? That is the first condition. Tell me, is it a function or not? This is not a function. Why? I need the reason. This is not a function, right? It indicates you are not clear the theories, right? Why? I already told you, you need to check 4 conditions. All the elements in the domain have a relation with the codomain, but it's not mandatory. All the codomain element have a relation with the domain, right? Second one. Third one is what? One domain element does not have relation with 2 codomain elements, but here 2 have a relation with this one and this one. So because of that, this is not a function, right? So we can say f is not a function, right? Yeah. Yeah, very good. We cannot have 2 connections. So it means one domain element have one domain element do not have 2 different outputs, right? If it is on that way, it is not a function, right? Maybe you can draw the diagram and find out. Other way, right? We know if it is a relation, first element is a domain element, right? So we can check for the domain element. For one domain element, is there any two things? So two is only, but if you look at here, two is occur two times, right? It is not possible. It means the domain element 2 with two relation, right? 2 to 3, 2 to 1. So it is not possible. Because of that, we can say f is not a function, right? Now we will look at for g, right? So what do you think about g? What do you think about g? So if you look at here, the first definition says each and every element in the domain must have a relation with the codomain, right? So they are giving domain have 4 elements, 1, 2, 3, 4. But if you look at here, 3 is there, right? 3 is there in the domain. 4 is there. 1 is there, but 2 is missing, right? So if you draw a diagram, you can easily understand. Even you don't need to worry about the diagram. Directly by looking at the function, also you can answer the question, right? So we know if it is a set of X with 4 elements, so in the domain and codomain, definitely they have the 4 elements, right? Now the first relation they are telling 3 to 1, right? This one. The second one they are telling 4 to 2. Third one they are telling 1 to 1. Now what will happen? The first definition says each and every element in the domain have a relation with the codomain. But here 2 is not relation with any element. So this is not a function. This is the way we can answer the questions, right? So if you look at the third one, right? Here the domain have 2, domain have 3, domain have 1, domain have 4, right? All the 4 elements in the domain have a relation. But if you look at here, the pair 2 comma 1, 2 comma 1 occurs 2 times, right? So it means they are defining the same relation 2 times, but it is a function. Why? If you plot the diagram, then you can easily understand, right? 1, 2, 3, 4. Here, 1, 2, 3, 4. Why I am putting 1, 2, 3, 4, 2 domain and codomain? This is a identical function from x into x. Depending on depending on this term, I am putting function x into x, right? My domain and codomain are x, right? So if you look at here, the first pair says 2 comma 1. So this one. Second pair says 3 comma 4. Third pair says 1 comma 4. Fourth pair says 2 comma 4, 2 comma 1, fourth pairs. But that one is already there. So I don't need to draw again, right? The last one, 4 comma 4. Right now, what will happen? All the elements in the domain have a relation with the codomain. So first condition is correct. Second condition is not mandatory. All the codomain elements have a relation with the domain. That is also correct. Second condition. Third condition, it is not possible one domain element have a relation with more than one codomain element. It is also true, right? Each domain element have only one relation, right? So third definition is correct. Fourth definition, one codomain element have more than one relation with the domain element, right? 4 is a relation with more than one. So it is also correct. So this is a function. So this is the way we can answer the question, right? So to check the function, you need to check all three. Yeah, it is a function, right? Even you have a confusion here. 2 comma 1 occur 2 times, right? 2 comma 1 means the same, right? This is an ordered pair. If it is a function, they are denoted as a ordered pairs. 2 comma 1, 2 comma 1. So if you have already 2 comma 1, you don't need to draw again, right? Between 2 and 1, only one relation, right? We can omit this one. So h is a function, right? This is the way we can answer this type of questions, right? So definitely you have some type of questions this way, right? So if you remember 4 conditions, then only answer the question, right? So answering in the sense, if you are not telling it is not a function, then you need to validate. You need to prove why you are telling this is not a function. That is important, right? No need the answer. The reasoning is important, right? If you look at this next question, right? Next question says, okay, A is a set, B is a set, C is a set, right? Now there is a function from A to B, another function from B to C, right? So the functions are denoted by the relation. So you need to plot these for f, you need to plot these for g. Depending on that, you need to find out the g of f. So they are asking about composition of functions, right? So first thing what you need to do, just you need to draw the diagram, right? Easiest way, just you can draw the diagram, right? So first they are giving a function from f, a, b, c, right? We know the elements of a, b, c. A contain a and b and c. B contain X, Y, Z. C contain R, S, T, right? First thing you need to do this, right? How you can do? They are giving the elements of A, giving the elements of B, giving the elements of C. So based on that, we can draw the diagram, right? After that, they are giving a relation from A to B. F is a relation from A to B. G is a relation from B to C, right? Now they are mentioning what is that relation is, right? So if F a relation from A to B, they are denoted this relation. They are denoted this function as a relation, right? So F is a function from A comma Y. So you need to draw. So if I write a function as a relation, the first element is the domain, second element is the codomain, right? This is the theory, right? If we write a function as a relation, that is, we can write the function as a relation as a ordered pair. The first element is a domain element, second element is the codomain element, right? So if a comma y is a first function, first relation, right? So a to y, right? Then the next one b to x, third one c to y, right? Now I completed the function f. Now I need to look at the function g. So the function g says x to s, y to t, z to r, right? So after I'm drawing this one, right, we know now they are asking g of f. G of f means what? This is a composition of function. So we know the theory, right? F is a function from a to b, g is a function from b to c, right? So g of f mean there is a function. G of f is a function from g of f is a function from a to c, right? We need to find out a function from A to C. That is g of f, right? In this question, they are asking to find out the g of f, right? So g of f means that is a function from A to C. That is the composition of function, right? We discussed composition of function, this one, right? That's a function from A to B, another function from B to C. The important thing, the codomain of the first function consider as a domain for the second function. That is important. Then we can write the g of f is a composition of f and g. It considers a to c, the function from A to C, right? So now we need to find out, right? We need to find out similar to this one. For g of f, we need to find out similar to this one. Similar to, we need to find out these pairs, right? This is a requirement, right? We don't know how many elements comes for this, right? How we can find out this one? First, you need to take, so g of f means there is a relation from A to C, right? From A to C, right? First, you need to take the first element. First domain element is what? From A. First domain element from A. So I can take A. Then the second domain element is B. Third domain element is C, right? So the third domain element is C, right? Now I need to find out the codomain element from C, right? How I can find out the codomain element from C, right? First I take the first domain element A. First I take the first domain element A. Then I need to find out this relation goes from A to Y, right? Then from Y, how I can travel to C, right? From A to Y is my first relation. From A, I need to move for the Y. Then only I can achieve the B position. From B, I need to find out how I can move for the C. To move for the C, I need to travel by this way, right? So now I can tell A and T is a relation. So the function g of f, I can denote a comma t. Similarly, I take the second element in the domain A. Sorry, second element domain A is B. Then from B, I can move. From B, I can move this way. Right from here, I can move this way. So my second element is B and S. Now, again, I can move from C to Y, right? Yeah, I miss one relation right here. Just look at here. I miss something. That's why it's not. If you look at the X to S is there. Then Y to T is there, right? Y to T, I forgot to draw, right? Y to T is there. Then Z to R is there, right? Then what will happen? If I if I take my third element C, it will travel this way. Then from Y to T, right? Then my third is C comma T, right? This is the answer g of x, right? They're asking find out the function g of f from A to C. So you need to answer this one, right? So now they are asking, right, image of f. So tell me what is the image of f? So what are the images of IM means what are the images of f? So what are the images of f? X, Y, Z. Is it correct? If I write this way, is it correct? So f is a function from A to B, right? We need to think the codomain elements of function f. So the codomain elements are x, y, z, but we are calling as an image if they have a relation with the domain A. But here z is not a relation with A, so we cannot put this one, right? So the images of f is x and y. Similarly, can you tell me what are the images of G? Tell me what are the images of G? So the images of G means here there are there are three elements R, S, T. All three elements have a relation with their domain B. So we can say R, S, T is the images. Similarly, can you tell me what are the images of G of F? What are the images of G of F? Tell me. What are the images of G of F? How you can check? For that one, just you can draw this, right? Or just you can check, let's say, so here you need to check what are the codomain elements. So T is there. So T is occur two times. So we are right only one T, then S. T and S are the images of G of F, right? So now we need to find out the images of G of F. How we can find out? So we know we can define function as a relation. So the second element is the codomain element. Right here, what are the elements we have? T and S, right? T occur two times, but we can put only one time. So T and S is the images of G of F, right? Any questions? So this way we can answer this type of questions, right? Okay, the third question, right? So now there is a function from R to R. Similarly, there is another function from R to R. R means that is a real number, right? So there is a function from real number to real number. So it means domain is a real number, codomain also a real number. That is they are explaining by this R to R, right? Now they are giving two functions, right? So first function f of x is equal to 2x plus 1. Another function g of x is equal to x squared minus 2, right? Now they are asking you find the formula of g of f, right? So depending on the definition, right, g of f means it is equal to g of f of x, right? Do you remember this one? We discussed, right? G of f means it is equal to g of f of x, right? Also, they are telling composition function, right? So now what will happen? You have a function f, right? Another function g, right? Now the domain of the the codomain of the first function consider as a domain for the second function, right? Now we need to find out a function. Let's say this is A, this is B, this is C. So now we need to find out the function from A to C. That is the composition of function, right? Now this question, they are giving f of x and g of x. They will ask you what is the composition function of g of f, right? They are asking g of f. So g of f means, now what will happen? From the definition, g of f is equal to g of f of x, right? G of f of x. Just look at here. We already discussed yesterday, right? So in the composition section, we discussed, right? So just look at here. So the g of f a is equal to g of f of x, right? So this definition. From this definition, we can draw g of f of x, right? Now we know the function f of x as well as we know the function of g of x, right? Now we need to find out g of f of x. Now we need to find out g of f of x, right? Now we need to find out g of f of x. How we can find out g of f of x? Already we know the function g of x, right? G of x is equal to x squared minus 2. So if I put x is equal to 1 means g of 1 is equal to 1 to the power 2 minus 2. If I put x is equal to 2, g of 2 is equal to 2 to the power 2 minus 2. If I put x is equal to 3, g of 3 is equal to 3 to the power 2 minus 2. Now if I put x is equal to k, g of k is equal to k to the power 2 minus 2, right? Similarly, if I put x is equal to 2k, what will happen? G of 2k is equal to, tell me, can you write this one? G of 2k is equal to, so for G of 2k is equal to, what will happen? So in this equation, right, I can replace x is equal to k. Now I am replacing x is equal to 2k. So G of 2k is equal to, just I can replace x by 2k, 2k to the power of 2 minus 2, right? Similarly, I need to find out, right, g of f of x, right? So g of f of x means I need to find out g of 2x plus 1, right? So already we know what is f of x. F of x is equal to 2x plus 1. Now I need to find out g of 2x plus 1, right? So how I can find out g of 2x plus 1? Just I can put in this question. In this question, previously I put x is equal to 2k. Now I need to put x is equal to 2x plus 1. If I put x is equal to 2x plus 1, g of 2x plus 1 is equal to, now what will happen? The place where x is there, I need to put replace with 2x plus 1, all thing to the power of 2 minus 2, right? So this is the function, right? How I can write? 2x plus 1 whole thing to the power of 2 minus 2. Then I can write this one. So this is similar to a plus b whole thing to the power of 2, right? Then I can write a squared plus 2ab plus b squared, the form, right? So I can write 4x squared plus 2 into a into b, 2 into, so I can write then 2 into 2x into 1 plus 1 to the power 2, 1 minus 2, right? Then I can write 4x squared plus 4x, right? Then, so this is multiplication, so we don't need to put this one, right? Then 1 minus 2 minus 1. So f of, sorry. So the function of g of f is equal to g of f of x. It is equal to this one, right? That's nothing, right? Just you can replace for the g of x. So g of x is equal to this one. For x, I need to replace f of x. F of x means 2x plus 1, right? If I replace this way, I am getting that is the function of g of f of x, right? Any questions? Any questions? Okay. From this one, I will stop, right? Then I will move for the next topic. Okay. Okay, I will explain again, right? There are two functions, f of x and g of x, right? They are mentioning in the question that is a composition of function, right? So composition means we already know f a to b. Similarly, another function g b to c. Then composition is right, g of f. G of f means that is the function from a to c, right? So already we know that definition, g of f is a composition function. Then we can write g of f of x. This is a definition, right? From the theory. Just look at this theory. So it means we need to find out a function. To find out the g of f is a composition function, we need to find out the function of g of f of x, right? So g of f of x means we already know what is g of x. We already know what is g of x, right? So here we need to find out g of f of x, right? So g of 1, g of 2, g of 3, we can find out. Similarly, g of f of x means f of x is equal to 2x plus 1, right? So now we need to find out g of 2x plus 1. How we can find out g of 2x plus 1? Previous case, we are putting x is equal to 1. We will find out g of 1 is equal to 1 to the power 2 minus 2. Similarly, if I put x is equal to 2, then I will find out g of 2 is equal to 2 to the power 2 minus 2. Similarly, if I put x is equal to 2x plus 1, then what will happen? G of 2x plus 1 is equal to, then for this x, I can replace this 2x plus 1, right? That's nothing. For all the x's, I can replace 2x plus 1. Now what will happen? 2x plus 1 whole thing to the power of 2 minus 2. Then if you sort this equation, then you are getting the answer, right? Right now they are telling, right, there is a function from a to b, b to c, c to d, right? There are three functions. F is a function, g is a function, h is a function. We need to find out whether it's which functions are one to one, which functions are onto, which functions are invertible. What do you think about this function f? F is a one to one or not? F is a one to one or not? Tell me how you can check is a one to one. There is more than there is no two more elements in the domain have a relation with there is with relation with the same image. But if you look at here, A and C are two different elements. They have the relation with one element too. So this is not one to one, right? This is not one to one. This is not one to one, right? Now, if you look at here, this is with relation with y, this is relation with x, this is relation with w, right? So now what will happen? G is a one-to-one function. Why? There is no two elements in the domain have a relation with the same relation with the codomain. If you look at this one, this is not one-to-one. Why? Here x and z, two different elements have the relation with the same in the codomain. So because of that, this is not one-to-one, right? Now, if you look at the onto function, right? The first one, f is not onto. Why if is not onto? Sorry. Yeah, if you look at here, this is not onto. Why it is not onto? If you look at this relation, right? The element, so if it is onto, each and every element in the codomain have a relation with the domain. So this must be relation with this, but there is no relation with this one. So because of that, we can say f is not a onto function, right? If you look at this one also, what will happen? G1, G is not onto. Why this is not onto? In the function G, that is the element, there is no relation with the domain B. So because of that, this is also not onto. If you look at this one, all the elements in the domain have relation with the, all the elements in the codomain have relation with the domain. So this is onto. This is onto, right? Here to check the invertible, this is to check this is not a invertible because this is not one to one, this is not onto. Here this is one to one but not onto. Because of that, this is not invertible. This is invertible, this is invertible. So there is no any function is invertible here, right? So this is the last one. Okay, then you can try the remaining things, right? Now they are telling you, right, there is a function from f, real number to real number, they are giving f of x is equal to 2x minus 3. Now they are telling this function f is a one-to-one function as well as this is one-to function. So this function is one-to-one and one-to. Definitely this function have a inverse function. So that is the conclusion we are taking from this, right? If a function is one-to-one and one-to, that function have a inverse function as well, right? So now they are asking to find out the formula for the inverse function, right? How we can do that? So in this type of question, they are giving you the equation for f of inverse x. So the thing here, y is equal to, we can write. Now we can write, this is my equation, f of x. X is a variable. Depending on the value of x, let's say y is equal to 2x plus 2x minus 3. Right? Depending on the variable change for x, my y value will change, right? This is my domain. This is my codomain, right? If it is an inverse function means, let's say from this is f, right? So now what will happen? If I change the value for x, the y value will change, right? Now what I need to do to find out the inverse function, only you need to remember, right? What I need to change the subject as a x, right? I need to change the subject as a x, right? How I can change the subject as a x? Y is equal to 2x minus 3. So y plus 3 is equal to 2x, right? If I move this one, y plus 3 is equal to 2x. Then if I divide it by 2 in both sides, right? Now x is equal to y plus 3 divided by 2, right? My equation says x is equal to y plus 3 divided by 2. Previous my equation, y is equal to 2x minus 3. In this equation, depending on the variable change x, the y value change. If you look at the second equation, depending on the variable change for y, the x value different, right? So this equation I already told you, f of x, the equation from x, depending on the value change for x, it will get different value for y. Here, this equation is f of inverse y. Why I am telling you f of inverse y, depending on the variable y change, this equation change. But I need f of inverse x, right? So this equation says f of inverse y is equal to y plus 3 over 2, right? Now if I need f of inverse x, right, then just I can replace y by x. So now what will happen? X plus 3 divided by 2. This is the equation they are asking, right? That is the inverse equation, right? Okay, I will stop here. Yeah, just you can practice for these questions, right? The supplementary problem you can practice. Also, you have the answers, right? So just practice yourself and check the answers, right? That's all about the functions, right? Now I will move for the uh, okay. Relations means you already know some relations, right? Yeah, just look at here. Okay, you have two numbers, right? Let's say you have a numbers, pair of numbers, 5, 10 and 20, right? Now we need to find out which value is the largest value, right? So maybe you can use greater than or less than symbol, right? If you use this less than symbol, this is a relation, right? So you have a two numbers, 10 and 20, right? How you can put this one? How you can put? So this is the smallest value, 10. This is the largest value, 20. So this is a relation, right? So relation is already you are familiar, right? So let's say you have a set A from 1, 2, 3, 4, 5, 6, right? Another set B, right, have odd numbers, 1, 3, 5, right? Now we can write B is a subset of A, right? So this is a relation, right? So relation means we are defining the relationship between two sets or two attributes or two values, right? That is we can call relations, right? So less than you already familiar, right? So sometimes you learn, right? If you have a straight line, y is equal to mx plus c. So mx plus 5, right? Then you will find out the parallel line for this. So you will find out the parallel line for this. So these two lines are relation, the parallel relations. Likewise, relations means you need to define the relationship between two attributes or two sets or two values. That is we can call relations, right? So relation means you are thinking or you are telling the existence or non-existence of something, right? If you have a 5 and 8, you will tell which one is the smallest value. So this is the smallest value. This is the largest value. So relation means you are telling existence or non-existence of certain connection between a pair of objects, right? So relation means definitely it has a pair of objects, right? Definitely it must be a pair of objects. To check the relation, definitely it must be a pair. Pair means two elements, A and B, two elements. So you are checking the connections between two elements, pair of elements, that is we can call relations, right? So just imagine you have a element, two elements A and B. So if you write this way, this is a pair of element A and B. The important thing in the relation, the order is important, right? Order of the element is important, right? So if you are considering the relation, this one is a we can call ordered pair, right? It means if you have a pair A comma B and you have a pair B comma A, they are not equal, right? That is important. So the order is important. A comma B is a one different pair. B comma A is a one different pair, right? That is the important thing. A comma B is a different pair. B comma A is another different pair, right? Both are not equal. But if you look at the set theory, right? If you look at the set theory, A is a set, 1, 2, 3, right? B is a set, 3, 1, 2, we can say A is equal to B, right? In the set theory, order is not important. But if you look at the relation, order is order is mandatory, right? Order of the element is mandatory in relations, right? So just look at here, A is equal to B and B, a pair A comma B, a pair B comma A, both are not equal. That is important in the relations, but not the case in the set theory. Set theory, the order is not mandatory, right? So if you look at here, 3 comma 5, one set contain, another set contain 5 comma 3. So then we can say both are equal sets, but not the case in relation, right? In relation, you need to think the order of the element. That is mandatory. The element order is mandatory, right? Similarly, we need to think about all the things as a pairs, right? Two elements we as a pair, we can say that is a relation. So relation in the sense we are considering the existence of or non-existence of certain connections between pair of objects, right? The important thing that pair is an ordered pair. That is important. So if it is a relation, all the things we are considered as ordered pairs, right? So ordered pair is nothing. The first element is A, second element is B, right? It is totally different from first element is B, second element is A, right? Okay, now next we will look at, right, product sets, right? The product sets. So the product sets means, just imagine you have a set A, right? You have a set A, let's say that contain A, B, C, three elements. You have set B, it have two elements, P and Q, right? Now, the product set means we can denote the product set as A cross B, right? So this is, if you look at somewhere else in this symbol, it says this is the product set of A and B, A cross B. We can read this one as A cross B. We can read this one as A cross B, right? We can read this one A cross B, right? So A cross B means that is the product set. So how we can write product set? Product set means it will write all the combinations with A and B, right? So if I take the first element A, right, I need to it means product set means I need to write all the ordered pair. So my first ordered pair A and P. A and P is my first ordered pair, right? Then A and Q is my next ordered pair. Then I take B, right? Then B comma P is my next ordered pair. Then B comma Q is my next ordered pair. Similarly, C comma P is my next ordered pair. C comma Q is my next ordered pair. So product set means A cross B. So A cross B means it is a set contain all the combination of A and B, right? All the combination, all the ordered pairs, right? So if you write all the ordered pair, if you write a set, this is a set with all the ordered pairs of A and B, we can write this one is a product or Cartesian product, right? So we can write this way, right? So now just think about, you have a set A with 1, 2, and 3, right? Now I am telling A cross A. It means what? A cross A means my both sets are A, right? Can you write the uh, product set or Cartesian product of A cross A? Now what will happen? So just you can think about here, another A is there, right? Now what will happen? I can take here 1, here 1. So 1 comma 1. Similarly, I can take 1 comma 2. Similarly, I can take 1 comma 3. Then if I take 2, 2 comma 1, 2 comma 2, 2 comma 3. Similarly, 3 comma 1, 3 comma 2, then 3 comma 3. So these are the uh, A cross A, right? All the ordered pairs, all the ordered pairs. If you write all the ordered pairs as a set, that is we can call product set, right? A cross B we can call, right? Now tell me, there is a set A with 2 elements. There is a set B with 3 elements, right? Now I need to find out number of how many. Now I need to find out how many ordered pairs for A cross B, right? How we can find out? For this example, how you can find out? So to find out how many ordered element, how many ordered pairs you are getting for this question, how many? Number of ordered pairs. For that one, number of elements in A multiple by number of elements in B, right? So number of elements in A, 3 elements, 3 into, in the B, 2 elements, 2. So altogether, 6 ordered pairs, 1, 2, 3, 4, 5, 6. This is the equation to find out number of ordered pairs, right? So similarly here, number of ordered pairs in A cross B. So number of elements in A multiple by number of elements in B. So number of elements in A, 2, multiple by number of elements in B, 3. So altogether 6 ordered pairs, right? If I take 1 here, 1A, 1B, 1C, right? If I take 2 here, 2A, 2B, 2C. I already told you, so in the relations, A comma B is totally different from B comma A, right? So if a product of A cross B is not equal to product of B cross A. Did you understand? A cross B is not equal to B cross A. Why? So if I look at A cross B, this one, right? Now if I consider B cross A, now what will happen? First I take the first element from B, right? So A. So A comma 1, right? Similarly, I can take first element from B. So B comma 1, then C comma 1. Similarly, I need to take this first element from A comma 2, B comma 2, C comma 2, right? So A cross B and B cross A are two different things, right?